Hello, my name is Alexander Gorlak, and I want to talk about the products of Yacht Devices, which entered the market about 10 years ago and were designed primarily for sailing vessels. However, in the last 10 years, marine electronics have made strides towards small vessels. You can find fish finding, sonar and navigation display on 4 to 6 meter boats now, and even autopilots. Let's start with our company's Autopilot. The device comes in a small box like this. In general, the Autopilot system itself consists of two parts. The power part is a hydraulic pump or an electric motor that controls either the angle of the rudder blade or the angle of the outboard motor, and the course computer, which, depending on the specified operating mode, sends commands to the actuator to turn, for example, the rudder blade to the right or to turn the rudder blade to the left. Our device has a battery connection. There is a connection to a reversible motor or a hydraulic pump. There is a connection to the clutch, but on this boat the clutch is not connected. The clutch completely disengages the steering wheel during autopilot control of the boat. If the clutch is not engaged, on the contrary, I can quickly turn and avoid any obstacle that appears on the water. And after that, the autopilot will return the boat to the set course. Additionally, buttons can be connected to the autopilot, any buttons of your choice, as our autopilot does not require the installation of an additional display. The only thing it requires for installation is a magnetic compass sensor, such as the Lorentz Point one or any other similar inexpensive compass. After that, you can control the autopilot either with the connected buttons or with the connected plotter, for example. On the Simrad plotter, the autopilot control panel appears where you can select the operating mode, such as waypoint navigation course following auto mode, or correct the course and use other operating modes. The new YDRP-05 Autopilot model coming out this year has a built-in Wi-Fi module. You can connect to the Autopilot using a mobile phone and access its built-in web server, where there are controls for the Autopilot on the page and Autopilot settings. The built-in web server also makes it easy to perform Autopilot calibrations, as well as monitoring and recording of diagnostic data. In principle, you don't even need to install anything, neither a plotter nor buttons, and you can control the Autopilot purely via Wi-Fi, but this, as you understand, is poor maritime practice, and we do not recommend doing this. The cost of this device is only $350, and the current model provides a continuous current of 10 amp and a peak current of 15 amp. The model being released this year provides a continuous current of up to 15 amp and a peak current of up to 20 amp. And this is sufficient for controlling vessels up to 10 to 15 meters in length. The second device installed on this boat is the circuit control. This is a digital switching unit which includes 4 relays. This is a bistable relay, and one might wonder why a digital load management unit is installed on such a small boat. Firstly, from a design perspective, we wanted to use these small buttons here, and it would be inappropriate to switch powerful loads such as a bilge pump or autopilot with these small buttons. Therefore, ideally, you should install, for example, an automotive relay here and switch these loads using the relay. By using our unit, we not only replace these relays. However, our module also uses bistable relays, meaning they consume electricity only at the moment of switching and do not consume it while holding. And this device, in operational mode, consumes only about 20 milliamps and provides 4 load channels that can be connected here. You can manage the loads either using these buttons, as there is a connection for buttons and a connection for LEDs, or it can be controlled via the NMEA bus. On Raymarine plotters, this can be done very elegantly, as they have special software which allows you to draw your boat and manage loads beautifully. On the Lorentz plotter installed here, it's not as appealing. Here you need to go to the route, then enter the season section, then go to the control icon, select loads, and then press the load management button. This is not very convenient. However, for certain loads, for instance, we can save space on the panel by not installing buttons. This boat is equipped with JBL speakers with lighting, which I use quite rarely, and therefore this load does not necessarily require a dedicated button. Lighting can be turned on through the multifunctional display, although it requires pressing 3 times instead of once. Again, the running lights, if you don't use them often, infrequently, even during dark hours, it's also possible not to have a separate button activating it through the digital switching unit. Several of circuit controls can be installed on the vessel and on larger ships. This also helps reduce cost of electrical wiring and reduce losses in electrical wires, because this unit can be placed directly next to the loads it controls. The third device that found its use on this boat is the Wi-Fi gateway. It is quite compact with a connector on one side for connecting to the NMEA 2000 network and a Wi-Fi module which you can connect to using a mobile phone, laptop or tablet and use almost all the marine software such as the free OpenCPN navigation software or any other software for navigation, Autopilot control and displaying boats data. Of course, 10 or 15 meter boats have a designated chart table where laptops are often used instead of multifunction displays for cost-saving purposes. On these laptops, course plotting is carried out and all navigation is performed. On a small boat like this, of course, it's not necessary, but why is this device here? It has a built-in web server with web gauges that you can connect to using a mobile phone and see all boat's data, such as depth or engine data. If our main display installed on the boat is occupied, for example, with sonar data, and we want to see some additional figures, Tsi can set up either a mobile phone or a tablet and use it to monitor boat's data or control the autopilot with the help of Wi-Fi gateway. The fourth device from our company, which also unexpectedly found its use on this motorboat, is the Ethernet gateway. It is very similar to the Wi-Fi gateway. One side has an NMEA 2000 connector and the other side has an Ethernet port RJ45. This boat is equipped with the Lawrence Structure Scan 3D module. It's a wonderful device, providing an excellent side scan image and an impressive 3D picture. Of course, you can see the current depth on the side scan screen, which you can display separately in the struct field. However, the plotter itself does not interpret this data as depth, meaning you can observe it, but it does not use this data when recording tracks. It does not transmit this data from the Ethernet network to the NMEA 2000 network, and consequently, for example, our autopilot cannot operate in depth following mode, which is very convenient when towing, for example, lures during fishing. If you configure the Ethernet gateway on the specified port, there is an article about it on our website, then it will transmit depth data from Structure Scan 3D to the NMEA 2000 network. For this, you will need a proprietary Lawrence cable. You can connect it either to the Structure Scan module or to an available port on the Lawrence plotter. It doesn't matter where the connection is made, and after that, our device starts taking depth data from the Ethernet network and transmitting it to the NMEA 2000 network, and accordingly, you get in the sources in the sonar section, depth data source. Depth data appears on the NMEA 2000 network, which can be used by the autopilot and other applications. The fifth device from our company installed on our boat is the battery monitor. A shunt is connected to this device. It is installed in our fuse box. There is one nuance here. If we take a powerful shunt that allows us to observe the starter currents, unfortunately the currents of small loads around 1-2 amps become indistinguishable from noise. Here, it was decided to connect a shunt, in my opinion, at 20 amps to see in detail all the loads created by the navigation system, to see all the loads created by the autopilot during use. We can go to the tools page and view the current and voltage of the boat's network on the Lawrence screen. The sixth device that could have been installed on this boat but isn't is the tank adapter. The device is similar to the battery monitor, and like the battery monitor, it is equipped with a microSD slot. Through this slot and memory card, the device can be programmed. Unlike other analog data converters from the fuel tank to digital form available on the market, it has three main differences. The first is that it works with all types of sensors. These include resistive sensors, voltage sensors, and current sensors. The second, a significant amount of work was done to ensure that our device could operate alongside any other indicators installed on the boat. When we connect, say, a resistive sensor to an analog meter, it introduces interference into the electrical network, and this parallel resistance needs to be accounted to get correct results. Here we can configure the settings for single coil and dual coil pointer indicators, as well as the electronic modules known to us, so that these modules continue to display correct data, and the correct data is transmitted to the NMEA 2000 network. Plus, here we have a 12-point calibration on the shape of the tank or water, fuel. That is, here you can program the tank type with which our device operates and program its capacity. This device will, firstly, allow you to keep your old equipment when upgrading your boat, and secondly, provide accurate information on how many liters of fuel you have left in the tank. The next device we could use on this boat, but also do not use, is the engine gateway, one of our most popular products. We also offer about a dozen different cables for various engines. It supports many different protocols. This is the basic JY939 Smart Craft for Mercury and Mercruiser engines, and several others, including the Suzuki protocol. Therefore, if you need to connect a Suzuki engine and want, for example, to save space on the panel by not connecting the Suzuki display, if your Suzuki display has malfunctioned and its replacement cost seems too high, you can install our engine gateway, which will also handle this task, allowing you to view all engine data on the navigation display. If you don't have a modern engine, but for example an old analog gasoline engine, as my last boat, which had an 80 horsepower Yamaha carbureted engine, and we have this outboard gateway device, which is this little tail. It wraps around the wire leading to the spark plug, and the device transmits the engine's RPM to the NMEA network, counting engine hours, and it transmits the NMEA network voltage as the generator voltage. If you want to, for example, also receive the engine temperature, you can install another one of our devices, an NMEA 2000 digital thermometer, and program the outboard gateway to take data from this thermometer and display it on the NMEA 2000 network, like, for example, coolant data. On my previous boat, under the engine cover, there was an NMEA 2000 block installed where the outboard gateway was set up along with a thermometer, and where our Wi-Fi gateway was installed too. Another Wi-Fi gateway was installed under the helm and connected to the navigation network, and accordingly we had a wireless bridge from under the engine cover to the helm, meaning two Wi-Fi gateways can function as a wireless bridge, eliminating the need to run a cable from the engine to the helmsman's panel. By the way, our thermometer is getting a new edition this year, which includes a Wi-Fi module. We also have a number of other sensors. Feel free to visit our website to learn more about them. You can connect to the thermometer using your mobile phone. You can view the entire measurements history as it is recorded in non-volatile memory over several months. You can easily change settings, for example, by pointing that it measures the temperature in the fish well. If you actually have a fish box with a water, you can connect our thermometer there and set it up so that it turns on the channel of the circuit control, which control a pump that refreshes the water in this box if it becomes too warm. This is quite an exotic scenario that in reality hardly anyone uses in practice except for a few individuals. Nevertheless, such an opportunity exists. All our sensors can manage digital loads. But if you really need some exotic scenarios, we have this wonderful device for that, called the Python Gateway. It has a USB slot for connecting to a computer and uploading program code in Python. It has an NMEA 2000 connector and an NMEA 0183 wires, but you can connect anything to the NMEA 0183 wires. For example, At the exhibition, we connected a button and an LED panel here, which was controlled using pulse width modulation. We also offer a special library that makes it very easy to write programs for processing NMEA 2000 messages and NMEA 01183. Welcome to our website, where you will find very interesting examples. And we have a similar device called the NMEA bridge, which has two NMEA 2000 or CAN bus connectors. It also allows real-time message processing between two bus segments. If you have any complex situations that need to be resolved in an unusual way, we have the tools for that. Additionally, on our website, you will find 15 more products that I haven't mentioned, which were not included in this short video. Welcome to our site, and thank you very much for your attention. Here's another unexpected use for our Wi-Fi gateway and circuit control. To avoid having to climb into the boat and turn on the bilge pump right now, we can activate it remotely using web gauges on a mobile phone. Just like that. That's the kind of automation we have. We also have, of course, the floating switch installed with the bilge pump, which automatically activates the pump, but it doesn't work that well. That's the story, and now just like that we can turn off this pump through web gauges.